Okay, for our first graph, we're going to look at y equals 4 sine of 2x, okay? So a couple of transformations are happening here. We do not have a vertical shift. There's no plus or minus any constant at the end of this. We do have a horizontal stretch or compression, and we do have a vertical stretch or compression. We do not have a reflection, okay? So let's go through the steps to graph this. The first thing we want to do is figure out what our period is going to be, okay? So the period we know is originally 2 pi, but we have some kind of horizontal stretch or compression because we have a value for omega. Omega in this case is 2. So we know that we can take t and take our original period and then divide it by omega. Well, that's going to be 2 pi. That's the original period of sine. And we want to divide it by omega, which is 2. So omega here is 2. So that's going to make my new period just pi. So that means instead of repeating every 2 pi, it's going to repeat every pi. So this is like kind of speeding up the graph. It's going to repeat more frequently is what I mean by that. Okay? So we know our new period is pi. So what we want to do is focus first on this region. I'm going to use green. We're going to focus first on this region from 0 to pi. We need to split it into the region for our 5 key points, okay? So remember, the 5 key points are ends, center, and quarters. So we've got the ends. We've got the beginning and the end of this period. Halfway between the beginning and end is pi over 2, so that's the center, okay? And then the quarters are halfway between the beginning and the center, and then halfway between the center and the end. So that's going to happen at pi over 4 and 3 pi over 4, okay? So back to the 5 key points. So we've got our 5 key points, okay? Well, we have them occurring at 0, pi over 4, pi over 2, 3 pi over 4, and pi. Now we have to remember sine, okay? Hopefully you remember that sine crosses through the origin, okay? So that tells me the end, or the beginning rather, of sine is going to be an x-intercept. And following that pattern, we know the ends and the center are going to be x-intercepts. So at this point in time, we know the x-intercepts of our graph are going to be at 0, pi over 2, and pi, okay? And then, so that's going to be an x-intercept, an x-intercept, and an x-intercept. And then we have to deal with the peaks and the valleys, the max and the min. So our graph leaves the origin and it goes up towards its peak. It goes back to the origin. It goes down to its valley and then back, not to the origin, but to the x-axis, okay? So origin to peak, x-axis to valley, back to the x-axis, okay? So let's figure out our max and our min, okay? Now we know we have an amplitude of, we take the absolute value of the coefficient, like the multiplier of sine, okay? So A is going to equal the absolute value of 4. So we have an amplitude of 4. So that means we're stretching our graph, okay? So what we need to do is think of the original peak and valley, okay? So we know that this is going to be our max or our peak. We know this is going to be our min or our valley. So here's what I do is I look at what the ordered pair would have been. We know that the range of the ordinary sine function is -1 to +1. So ordinarily, I would have pi over 2 and then comma 1. But it's no longer going to be 1 now because I need to stretch my graph. So what I can do is I can take the y coordinate of my max and min and multiply it by my amplitude. So that's going to make my max, that should be pi over 4 right here. Make that pi over 4, please. So that's going to make my max pi over 4 comma 4. So I'm going to have to go all the way up here for my max. And then my min occurs at 3 pi over 4. And ordinarily, the minimum value of sine is -1, but I need to take that now and multiply it by my amplitude. So I'm going to take -1 times 4. So that makes my new min 3 pi over 4, comma, -4. So I'm going to have to do like this. So if we were to look at one cycle of sine, it would look like this. Now we have room for two full cycles, so let's continue this. So let's look at the period now shifting from pi to 2 pi. So we know at the beginning and the end, so the ends, the edges of the period, we're going to have x-intercepts. We're going to have an x-intercept at the center, and then we're going to have a peak at the first quarter and a valley at the second quarter. So I can extend this. So that's graphing. This is a fairly easy example, I will give you that, but that's graphing transformations on pi. We had a horizontal compression and a vertical stretch, okay? So remember, omega is going to basically represent a horizontal compression or stretch, so it's either going to shorten our period or extend our period. So the graph is either going to cycle more frequently or less frequently, in this case, more frequently. And then we got a big old tall graph now. So the amplitude, the difference between the max and the min is now greater. Okay, so that is our first graph. Now, for some reason, and please forgive me for this, I try. Okay. I didn't give you quite enough room to do your work on this one. I made the actual graph a lot bigger. So, oops, sorry about that. So I'm going to fix mine and make mine a little bit smaller so I have more room to write. You don't have that luxury on your worksheet. Okay, so this time, for example 9, we're going to look at y equals -5 times cosine of -pi/2x. Okay, so we have a few things happening. We first need to acknowledge the fact that omega is negative. Okay, we don't want omega to be negative. We have somewhere in here, let me scroll back a little bit. So if we go back here, when we were first learning about these transformations, we learned that omega needs to be positive before we find the amplitude of our graph. So let's go back down to example 9. And what we need to consider is the even or oddness of these functions. And what we learned in the previous section is that cosine is even, okay? So since we know that cosine is even, that tells me that if I have cosine of negative theta, it equals cosine of theta. So opposite inputs yield opposite outputs. So we can basically pull that negative out front and then it just sort of disappears. It doesn't really do anything because if we have negative theta, it's the same thing as just cosine of theta. So we're going to first start by rewriting this graph as an equivalent form of this graph, just taking into account the fact that this is even, okay? So this is the same as -5 times cosine of +pi/2 times x, okay? So you need to first always make sure omega is positive before you look at the amplitude, okay? And in this case, we have a coefficient, we're going to call it a coefficient, a multiplier on pi that is negative. So this -5 means a couple of things. One, it means we have a vertical stretch to our graph. So the amplitude of our graph is 5. So that tells me that the max and mins are no longer going to be 1 and -1. They're going to be 5 and -5. So this is the amplitude of the graph. But that -5, okay, we're going to say not the negative. We'll just say the negative. The negative indicates a reflection about the x-axis. So this is not only stretching cosine, it's flipping cosine about the x-axis. So this indicates a reflection about the x-axis. Okay, so we need to just acknowledge that first. Okay, so we know we have an amplitude of 5. We also know that we have a reflection about the x-axis. Okay, so that's going to stretch and flip. Now let's talk about the period. Okay, so we know the original period of cosine is 2 pi. Well, to find our new period, we say t equals 2 pi over omega, where omega is the coefficient of x in that argument. So we're going to take 2 pi and divide it by omega. So that's 2 pi divided by pi/2. Well, that's 2 pi divided by pi/2. And remember, from just basic work with fractions, we have 2 pi times 2 over pi. Well, the pi's cancel, telling me that my new period is 4. The cool thing about that, that's a little wacky because we've gotten really kind of hopefully used to dealing with pi. But what's nice about that is it's going to be super easy to work with. So when the period ends up being just an integer value, it's like extra nice, okay? So our period is now 4. Let's talk about the 5 key points, okay? So first, let's just acknowledge one period of this. We start at 0 and we go to 4, okay? Now we need to split the region from 0 to 4 into 4 equal size pieces, okay? So we need to acknowledge halfway between 0 and 4 is 2. That's the center of this period. And then halfway between 0 and 2 is 1, and halfway between 2 and 4 is 3. That becomes the quarters of this graph. So we have the ends, that's the beginning and the end, the center, and then the quarters, okay? So we've got 4 equal size regions, 5 key points. Let's talk about the key points, okay? So our key points are now at 0, 1, 2, 3, and 4. And we have to remember that with cosine, the x or the y-intercept is at 0, 1. So that tells me that the initial start of cosine is a maximum. Okay, so initially it's a maximum. So we know that the key points, the x-intercepts are going to happen at the quarters, and then the max and min are going to happen at the ends in the center. So let's go ahead and just acknowledge our x-intercepts. Those are easy. So we're going to have x-intercepts at the quarters of the period. So this is 1, 0, and 3, 0. So this is an x-intercept. This is an x-intercept. Okay? Now, when it comes to the max and min points, what you do is you acknowledge what the initial max and min of cosine were. So originally, the min of cosine is -1, the max of cosine is +1. So what we're going to do is we're going to start by writing these ordered pairs with their x coordinates. And then what we do is we can take what would originally have been the y coordinate and we multiply them by this right here. Okay, so you multiply them by a. All right, so I know that if I was at 0, I would have originally been here at 1. That would have been my original y-intercept. So I would have had 0, 1, but I need to now multiply that by -5. So that gives me the point 0, -5. So this beginning of the period is now a minimum because remember, we're reflecting our graph. So not only were we stretching it, we're reflecting it, okay? So then at 2, that would have originally been a minimum. So that would have originally been down here, okay? So we would now take -1 and multiply it by -5, and that gives me 2, 5. So that's now a maximum, okay? And then finally, 4 would have been a max because we would have had a max, x-intercept, min, x-intercept, max. So that would have put me originally at 1, but I need to multiply that by a, which is -5. So that gives me the point 4, -5. So that becomes a min. So at 4, I'm down here at -5. So let's see what our graph looks like. Let me erase these little pretend points. So cosine that's reflected, stretched vertically, and then stretched or compressed horizontally would look like this. Now let's keep this going. Let's see if we can draw 2 more cycles of -5 cosine of pi over 2x, okay? So we would have an x-intercept here, an x-intercept here. We would have an x-intercept here and here, okay? We would have a max here, okay? And then we would have a min, let's see, we would go max here. And then we'd have a min here and here, okay? So if we were to keep this cycle going, we would go back up to the x-axis, we would peak back down to the x-axis, and then we would have a valley. At this valley over here on the y-axis, we would go back up to the x-axis and peak back down to the x-axis, and then we have a valley. Okay, so that would be the graph of -5 cosine pi over 2x. Okay, let's do one more graph and then we're going to look at a graph and come up with an equation. So again, I didn't give us a ton of room here, so I really am genuinely like sorry about that. Okay, so I'm going to shrink it for myself so I have a little bit more room. Okay, so what do we have going on here? So for example 10, we have y equals 4 sine of pi over 2x minus 2. So this time we do have a vertical shift, okay? So let's first talk about the period, okay? So I can see here that omega is positive pi over 2, so I don't have to do any of that even or odd stuff. It's just pi over 2. So my period, remember, is t, or if you want to be fancy, tau. We put our original period of 2 pi, and then we divide it by omega, which is pi over 2. So that's 2 pi divided by pi over 2, which is 2 pi times 2 over pi, which is 4 again. So maybe that's not terribly exciting that we have a period of 4 again, but at least it's easy to work with. So we get our period is 4. Okay? Now we know that the amplitude is the absolute value of A. So A is 4, so our amplitude is 4. So we're stretching our graph. This time we are not reflecting it. We're just stretching our graph, okay? And then we do have beta of -2, which is a vertical shift down. So down 2 units, okay? So when we are graphing those 5 key points, the x-intercepts are just x-intercepts, but for those peaks and valleys, the max and mins, we have to multiply them by A, and then if there's a shift, we have to address the shift then, okay? So we'll try to do these nice and slow because two things are happening to our max and our min points, okay? So let's first address our period. So our period is now from 0 to pi or no, 0 to 4. I don't know where pi came from, 0 to 4, okay? And then remember, we're splitting the region from 0 to 4 into 4 equally spaced regions or lengths, okay? So the center is at 2. The first quarter is halfway between 0 and 2, or 1. The second quarter is halfway between 2 and 4, which is 3, okay? Now, when you're dealing with sine, try to remember the y-intercept is at the origin, okay? And if you can remember the y-intercept of sine and cosine, you can remember the peaks and valleys and then the x-intercepts. So I know my first x-intercept is here. And following that pattern, my x-intercepts are going to be, remember, ends and center. So my x-intercepts are at 0, 2, and 4. So if we look at those 5 key points, we have 0, 1, 2, 3, and 4. So we have an x-intercept here, x-intercept here, x-intercept here, and then our ends and center, those are taken care of. So we now need to address our quarters. So our quarters are our maxes and our mins. And if you'll remember, when you're drawing sine, you start at the origin, and then you go to a peak, and then you go back down to the x-axis to a valley, back to the x-axis to a peak, back to the x-axis to a valley. So our first quarter is going to be a peak, and our second quarter is going to be a valley. So let's talk about our peak. Okay, now our peak is going to have an x-coordinate of 1. Now, ordinarily, the highest point on sine is 1. So we have to do two things now. We have to multiply sine by A, and then we subtract 2, because remember, this graph is going to shift, okay? It's going to shift down. So we're going to take the original y-coordinate of 1, we're going to multiply it by 4, and then we're going to subtract 2, okay? So that would give me, originally I had 1, 1, and then if I multiply it by my amplitude, I get 1, 4, and then finally, if I subtract 2 from the y-coordinate, that shifts my graph down. So I have the point 4, or 1, comma 2. So that is my max, okay? Now for the valley, that's our min. We would have had this occur at x equals 3. Now remember, ordinarily a valley, or the min on sine, is -1, okay? So my original y-coordinate would have been -1. I now need to multiply it by A and then subtract 2. So let's see what those points would have looked like. I would have ordinarily had 3, -1. But then when I multiply that by 4, I get 3, -4. And then when I subtract that shift, when I actually take my y-coordinate and shift it down to, That makes my minimum 3, -6. Okay, so the points we actually want to graph are here and here. So this is our peak, which is again the max, and our valley, which is the min. Okay, so we would have our min here at 3, -6. Okay, now here's the issue. The x-intercepts we need to plot initially so we know where they're supposed to be, but x-intercepts also have to shift. Okay, so I like to shift my x-intercepts at the end. That's my personal preference. You may want to do it differently. So let's look at our x-intercepts. Okay, so this x-intercept, we need to scoot it down here. This x-intercept needs to scoot down here, and this x-intercept needs to scoot down here. So all of those points shift down 2. So as not to confuse, let's scoot those and that one. Okay, now let's draw. So we start at our first x-intercept, which is now shifted down 2. We go up to our peak. We go down to what was our old x-intercept, to a valley, and then we go back up. Okay, pretend I actually hit this right here. Let me see if I can draw that better. Okay, now if we wanted to continue this, we could. Okay, so we're going to have another, x-intercept here, 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 and here. Our peaks and our valleys, we're going to have a valley here and a peak here. If we follow the pattern, we have a peak and a valley. So let's keep this graph going. And pretend I actually hit those points instead of getting close to them. Okay, so there you have it. So I figure out my x-intercepts. I lightly graph them so I know where they're supposed to be. I then figure out my max and min, and I do all the transformations on those y-coordinates of the max and min, and then at the end I fix my x-coordinate. Some people will fix the shift first, and that's fantastic. If you want to do your vertical or your horizontal shift first, that's great. So what some people will do is they'll do their shift up or down, and they'll draw like a dotted line and they'll treat that as their x-intercept. That is absolutely fine. You can do that as well. Okay. So finally, what we're going to do for topic 5, I'm just going to do it all in this one video just for the sake of wrapping things up quickly for myself. We're going to look at a graph and see if we can find the function that represents that graph. Okay, so for example 5, we have, or topic 5 rather, we have finding functions of sine and cosine. I'm not going to test you really hard on this. I want you to understand very basics, okay? So don't get too bent out of shape about this, okay? Now it says we're going to do 2 things. We're going to do just finding an equation based on information, then we're going to look at the graph. So for example 11, it says find each equation. For part A, it says find an equation of the form y equals a times sine of omega x if a is 3 and t is 4. So they're telling us our period is 4, okay? So if our period is, or 4 pi, if our period is 4 pi, what would omega be? So we have to kind of go about this backwards, okay? So we know ordinarily our formula for the period is whatever the initial period is. So for sine and cosine, that's 2 pi over omega. Well, we're told that t is actually 4 pi. So we want to take that and plug it in for t. So we get 4 pi equals 2 pi over omega. If I were to solve this, I would multiply both sides by omega first. The omegas on the right cancel, leaving me with omega times 4 pi equals 2 pi. Well, in order to get omega alone, I need to divide both sides by 4 pi. So 4 pi's cancel on the left, leaving me with just omega. And then on the right, the pi's cancel, and then 2/4 reduces to 1/2. Okay, so now we have that omega is 1/2. We know that a is 3, so all we have to do is fill in a and omega. Okay, so we would say, okay, well, y equals 3 sine of 1/2 x. Okay, so the hard part here is dealing with the omega, figuring out what omega is going to be in your equation. Okay, so for this one, it says find an equation for the following graph. These can be a little bit tricky. So the first thing I want to do is look at the y-axis, okay, because we know sine goes through the y-axis at the origin, and then cosine goes through the y-axis originally at 1. Now that can of course be stretched or compressed depending on the value for a, but it would ordinarily go through at 1. Now, if we have a situation where a graph goes through at -1 or some negative value on the y-axis, that would indicate a reflection, okay? So that would tell me that A would be negative, okay? So I can see that this is, let me kind of highlight it so you can see it better. Um, let's do blue. So this right here is my y-axis, okay? And I can see that down here, my graph is crossing at -2, and then it's following, the pattern from there. So that tells me right off the bat that I'm dealing with cosine. Okay, so I can tell you right now, I know I'm dealing with cosine, and I know that cosine has been reflected. Okay, so I'm dealing with a reflected version of cosine. So A is negative. Okay. Now, when we're looking for what A is, it's basically half the distance between the max and the min. So if I look here, I have a max at 2 and a min at -2. So to go from 2 to -2, that's 4, and half of that would end up being my amplitude. So divide that by 2, and I can say that A is -2. Negative because we reflected, and then 2 for the actual amplitude. Okay, so we know that much so far. So right off the bat, I can say that we have y equals -2 cosine. Okay, now we have to look at what the period is. Okay, so the period is basically for cosine, it's going to be from a max to the next max. Okay, but since we've reflected this, it's going to be from a minimum to a minimum. So if I look here, let's do this in, I want a color that's really going to stand out. Let's erase and then do blue again. Okay. So I know that cosine has been reflected. Okay. So if I look at this max or this min compared to this min, I've got one full cycle of cosine. So it's doing the full cycle right here. And I notice I'm going from 0 to 2 or to pi over 2. So that tells me my period is pi over 2. So since my period is pi over 2, we're going to have to do some work to figure out what omega is. Because remember, we need to know what omega is. So basically, we have this right here. We need to figure out what omega is, multiply it by x, and we're done. Okay? So we know that t represents the period, and it's the initial period divided by omega. Well, we have found out that the period of this graph is really pi over 2. So I'm going to replace tau or t with pi over 2. I'm going to set it equal to 2 pi over omega, and then I can solve for omega. And you have different ways you can solve for this. I see a proportion, so I'm going to cross multiply and then solve for omega that way. So we multiply diagonally. So I get pi times omega equals 2 times 2 pi. So I get pi times omega is 4 pi. Divide both sides by pi, and we have that omega is 4. So that's the last piece I need here. I know my amplitude is 2. I know that I'm reflected about the x-axis, which makes it -2 times cosine. And now I know that omega is 4. So this right here is the equation or the function that represents this graph right here. Okay, so again, I'd like you to understand how omega works as far as the period is concerned and the amplitude and reflections. It's important to know this. I'm not going to test you on really, really hard examples of this. This is as hard as it would get. Okay, so there you have it. That was a long video, but we got all 4 examples in right in time. Okay, so make sure you understand reflections, amplitude, period, shifts. When it comes to the shifts here, there's a few different ways you can do it. This is how I like to do it. We can look at other ways when we're together in person. Okay.